Hi, so for this video I'm just going to do a quick discussion about problems 10 and 11 in the pack. This is the free response packet. 10 and 11 have to do with differential equations. In this first problem, we were supposed to give you a axes to sketch the slope field. That didn't copy through. So what you can see what it would have looked like is this one here up at the top right of my answer key. On the AP test, if they're going to ask you to do a slope field, it's usually going to be 6 to 9 points at most. One key is you got to make sure you don't do any extras. Notice this one doesn't have any dots at when y equals 0. So don't fill those in. Just do the 6 dots or however many it is that they ask for. I see that's just plugging in x and y values to the differential equation and then sketching out the slope. For part B, it says find the second derivative in terms of x and y. So we can do the derivative of the left side and the derivative of the right side. That gets us the derivative of dy dx is the second derivative, and then the derivative of the right side we have to do implicit, so derivative of 2x is 2, and then minus dy dx or y prime. And since dy dx was given to us, we can plug that in, and so we know that the second derivative ends up equaling 2 minus 2x plus y. Now, determine the concavity of all the solutions in quadrant 2. So in quadrant 2 means I have x is negative and y is positive. And if I plug negative values for x and positive values for y, this will always be positive. So if my second derivative is positive, then that means it's concave up in quadrant 2. For part C, I have y equals f of x is the particular solution with the initial condition f of 2 equals 3. Do we have a relative minimum, maximum, or neither at x equals 2? Justify your answer. Well, if y equals f of x is the solution to this differential equation, that means dy dx is going to equal this. So this is our slope anywhere on that. And I can find the slope at at that point 2, 3 by plugging in 2 and 3 to the differential equation. We get 1, and in order for there to be a relative maximum or minimum, we would have the slope to be 0, and it's not. So it's not a critical point, so it has neither a max or a min. And then in part D, we are actually not even going to talk about part D. It's kind of all three of us calc teachers think it's sort of a silly question. You can look through the answers here. It's not worth our time. Okay, then let's flip the page and look at problem 11. This one might look familiar. I think we actually may have done this one in class earlier this year. Here you can see they do give us the place to draw your sketch of the slope field. In part B, I like this one. It's simpler than it seems. Again, read through it. It says it's this y equals f of x is the particular solution to the given differential equation, which means I can find the slopes of f of x using the differential equation. They give us initial condition, f of 2 equals 3 again, and this time write the equation for the tangent line. Okay, so this is sort of a two-part thing. Write the equation for the tangent line at x equals 2, and then use your equation to approximate f of 2.1. Okay, so don't overthink this too much. We've got go one part at a time. Tangent line, I need a slope and a point. They gave us the point, it's 2, 3, and then the slope we can use our differential equation for. So we plug in 2 for x, 3 for y, you get 9. And then just point slope form, y minus 3 equals 9 times x minus 2. So write an equation. I would probably actually box that in because that's your equation. And then if we are going to use it to approximate f of 2.1, probably should add the 3 over, so that's where I got to here. That y is f of x, right? They tell us y is f of x. So then f of 2.1 is approximately 3 plus 9 times 2.1 minus 2. Leave it there. No need to make a mistake and simplify it, but if you do, you get 3.9. Part C is kind of our typical differential equation problem that we're pretty used to, of finding the particular solution, actually finding it, given an initial condition. Here's where we do our separate the variables, and then so I get the y squared over 1 over y squared there, dx to be with the 1 over x minus 1. We integrate both sides, and the left side, just reverse power rule, negative y to the negative first. The right side, this is our natural log one, 1 over u. So 1 over x minus 1 is natural log of absolute value of x minus 1 plus c. We could plug in our x value and y value to solve for c, and we get that it's negative 1/3. So now I'm negative 1 over y equals that. I chose to multiply through by negative 1, so I just have 1 over y, and then I'm going to, you can just reciprocal both sides. 1 over y, flip it over, it becomes y. Flip this over, it becomes 1 over 1/3 minus natural log of, should be absolute value there, x minus 1. That's it. Alright, so your homework is to try the next one, number 12. Thanks for watching.